Hello there, Mr. Sutton here with the IM374 Extra Practice Number 2 solutions on right triangle trigonometry applications. On this problem, we have Herobrine, who I think is some character from Minecraft, maybe like a mod from Minecraft or something. I had to look it up. Apparently, his summoning tower is 20 blocks tall, and you're looking at the tower at a 10-degree angle of elevation. We want to know how far away you are from the top of the tower. Okay, so we have an angle of elevation. That's a right side up right triangle, like so. So here's the tower over here. Here's you looking up rather, at Herobrine's summoning tower. The tower's 20 blocks tall. So that's this height of the tower, 20 blocks. And you're looking at it at a 10-degree angle of elevation. So that's a 10 degree between the horizontal and the hypotenuse of this triangle. We want to know how far we are from the top of the tower. So that's this diagonal distance here, this hypotenuse, which we'll call x. So for this, we're going to use some kind of SOHCAHTOA here. We've got the opposite side across from the angle. We've got the hypotenuse we're looking for. Opposite hypotenuse, that's the SO part of SOHCAHTOA. So that's sine equals opposite over hypotenuse. So we can write sine of 10 degrees equals the opposite side of 20 over the hypotenuse x. And to get x, we just have to multiply by x and divide by sine of 10. So that's 20 over sine of 10 degrees. Let's see what the calculator has to say about that. So here we go, plugging that in. And it looks like, let's see, 115.2 if we round that off to the nearest tenth. So we've got 115.2 blocks away from the top of the tower, whatever a block is, a Minecraft block. For this problem, if you're standing 26 feet away from a tree and the angle of elevation from where you're standing is 39 degrees, presumably to the top of the tree, we want to know the height of the tree. So angle of elevation, we've got a normal right side up right triangle. Here's you. Here's the top of the tree over here. You're 26 feet away from the tree, so that's this base of the triangle. And then we have an angle of elevation of 39 degrees, so that's the angle between the horizontal and the hypotenuse of the triangle. And the height of the tree, that's this vertical side of the triangle. So now we need to find x based off this situation. So looking at the types of sides that we have, we're going to use some kind of SOHCAHTOA. We're looking for the side across from the angle. That's the opposite side. We have the side that's touching the angle but is not the hypotenuse, so the adjacent side. Opposite and adjacent, that's the TOA part of SOHCAHTOA. So we write tangent equals opposite over adjacent. And that's going to be tan of our angle 39 degrees equals the opposite side we're looking for, the x, over that adjacent side they gave us, the 26. To solve for x, I just have to multiply both sides by 26. So that's 26 times the tan of 39. And let's do that on the calculator. So doing that out on my calculator, pressing enter, we end up with 21.1 if we round that off. And that is going to be in feet, so that is how tall our tree is. For this one, we have a straight road going to the top of a hill, and this road is 2,500 feet long, makes a 12-degree angle with the horizontal. We want the height of the hill. So since we're going up here, and we have a 12-degree angle with the horizontal, probably going to use a right side up triangle. So this straight road here is the hypotenuse of the triangle. Here's the bottom of the hill, here's the top of the hill, so 2,500 feet between those. And then we have this 12-degree angle between the horizontal and the hill, so right down there. It's an angle of elevation. We want the height of the hill, so that's this vertical side of the triangle. We'll call that x. And now to get this value, well, since we're looking for the opposite side, the side across from the angle, and we have the hypotenuse, opposite hypotenuse, that's going to be the SO part of SOHCAHTOA, so we use the sine function. Sine of theta equals opposite over hypotenuse. So we can write sine of the angle they gave us, sine of 12 degrees, equals the opposite side x over the hypotenuse 2,500. To actually get x, we just multiply both sides by 2,500. So 2,500 times sine of 12. And let's see what the calculator has for us for that. So crunching those numbers, we end up with 519.8, and that's going to be in feet. So that's how high that hill is. For this problem, we have a 25-foot ladder leaning against a building. The ladder's base is 13.5 feet from the building. We want the angle the ladder makes with the ground. So since it's the angle with the ground, we're talking about an angle of elevation. So that's a right side up triangle here. So the hypotenuse is our ladder. The building is this right side of the triangle, and the ground is the bottom. So 25-foot ladder. That means we have a 25-foot hypotenuse. And the base is 13.5 feet from the building. So that bottom distance here, this is the distance between the base of the ladder and the building, so 13.5 feet down there. We want the angle the ladder makes with the ground, so that's x for this angle of elevation between the horizontal and the hypotenuse. So in terms of which sides we have, it looks like we have the hypotenuse and the non-hypotenuse leg, the adjacent side. Adjacent and hypotenuse is the ka part of SOHCAHTOA, so we need cosine of theta equaling adjacent over hypotenuse. So we can say cosine of x equals the adjacent side of 13.5 over the hypotenuse of 25. And now to actually get x, I need inverse cosine of 13.5 over 25. Let's do that on the calculator. So plugging that in using second cosine to get cosine inverse, I end up with 57.3 degrees. On this problem, we have a fire spotted by a ranger in a fire tower 30 feet above the ground. We have an angle of depression from the ranger down to the fire at 18 degrees. We want to know how far the fire is from the base of the tower. Well, since we have an angle of depression, we've got an upside down triangle. We have our ranger up here at the top of the triangle spotting this fire down below at the bottom. And they said the tower itself was 30 feet. So which side of the triangle is that? Well, the tower's over here. So this is a vertical distance right here of 30 feet, but that is the same as this vertical side of the triangle over here. So we'll put the 30 feet on this side. And then they said the angle of depression was 18 degrees. That's the angle between the horizontal and the hypotenuse. So that's this angle right here in the triangle. And we want to know how far the fire is from the base of the tower. Well, the base of the tower is down here. We want this distance between here and the fire, this distance. But since we need to put that on a side of the triangle, this top side here is the same as that distance. We'll put the x up here. And now to get that x, looking at the sides that we have, the 30 feet, that's the opposite side, the across side from the angle. This x up here, that's the adjacent side. It's the non-hypotenuse leg touching the angle. So we have opposite, we have adjacent. That's the TOA part of SOHCAHTOA. So we need tangent of theta equals opposite over adjacent. So that means we have tan of 18 degrees equaling the opposite side of 30 divided by that adjacent side of x. And now to get x, we have to multiply by x and divide by tan of 18. So we have x equals 30 over tan of 18, which we now go to the calculator for. And plugging that in the calculator, that comes out to 92.3, and that is in units of feet.